Saturday night party here. We're having so much fun doing the unit circle. I mean, it's Saturday night for me. It's not Saturday night for you. It's probably like Monday afternoon or something boring like that. It's technically Sunday now, though. It's the 26th, so whatever. Don't got to go to church in the morning. Just kidding. Live stream it. Okay. Be good kids. All right. See ya. Okay. So we were here, right? We were here. Right here. And we just got done. We did the whole unit circle. Again, if this was done in class, you'd have to memorize that. I'd do a whole quiz on it. But let's talk about how it's applied. And again, this is just a memorization tool, right? A memorization tool to find the sines, cosines, and tangents of any of those angle measures. Think about it. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points along that unit circle that you know sines, cosines, and tangents of all of them without needing to look it up in a table or without needing to try to figure it out within your calculator or the sine, cosine, exact values, not just like guessing around about it either. Like, because think about the cosine of 30 degrees, cosine is the x value. So like, look at the x value right here. Like that's radical 3/2. If I do cosine of 30 degrees, I take cosine of 30, and now I'm hoping that my calculator's in degree mode. Okay, it is. If I say cosine of 30 degrees, it's going to give me a weird answer because it can't calculate. It can't tell me radical 3/2, right? Even if I try to say, okay, put it into a fraction. Oops, whoa. Even if I say put it into a fraction for me, it's not going to do it because it's an irrational number. It cannot be put into a fraction. Now, if I take sine of 30 degrees, the y value is obviously just 1/2, sine of 30 degrees. So that one, I guess I could logically, whatever. I could see it in my calculator, but still, you shouldn't need to go to your calculator, right? This is one of those things that as you get further and further along in your math careers, it's going to be even more and more valuable to just know these things. Just like, 9 times 9 is 81, right? You just know that. You just got to start knowing these things, okay? I know it seems a lot to just know, but yeah. Okay, again, cosine is the x value, sine is the y value, tangent is y divided by x for any of these values. So I'd like you to have your unit circle right there with you. I'm going to have to flip back and forth to mine because I don't have one printed out. Maybe I'll just try to keep it from memory, see if I remember any of these things. But we're just going to work on some of these values. Okay, you use the unit circle to find the exact value of each trigonometric function. Okay, so cosine of 225 degrees. This is what I'm looking at here. Cosine of 225 degrees. Well, cosine tells me I'm looking for an x value, right? I'm looking for an x value at 225 degrees. So I'm going to go back to my unit circle. I'm going to look for 225. I'm going to have to scroll down a little bit. 225 degrees right here. And then I want to say the x value. The x value, negative radical 2/2. Negative radical 2/2. That's the exact value of cosine of 225 degrees. Okay. Let's find the exact value of sine of 120 degrees. Okay, the sine value, that's telling me I'm looking for a y value. Okay, a y value where? At 120 degrees. So find 120 degrees in your unit circle right here. And I'm looking for the y value, radical 3/2. So I go back, radical 3/2. And that's my answer. Okay. Tangent of 5 pi over 6. Okay, so tangent, again, is y divided by x. And so I go to find 5 pi over 6, and I see it right here. Okay, and so the y value is 1/2, and the x value is negative radical 3/2. So I've got 1/2, and the x value is negative radical 3/2. Okay, I'm just going to double check on that, make sure I got my x's and y's straight. Negative radical 3/2, look at 5 pi over 6, negative radical, okay, x comma y, good. All right, so now when you've got something like this, I like to just write it out like this. And just so I know I'm doing this right, turn it into a keep change flip, negative 2 over radical 3. cross reduce, -1 over radical 3, but we know we can't leave it like that. We have to rationalize negative radical 3 over 3. That is my answer. Okay. Y divided by x. Tangent 240. Okay. Again, tangent is y divided by x. So tangent of 240, I go to 240. I find it right here. Okay. Again, it's y divided by x. So it's got the radical 3 on top. Okay. So I've got radical 3 over 2 divided by 1/2. I've got to think about it. 240 is down here, right? Yeah, so that means it's a negative, 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 which will cancel out in the end anyway. All right, so this gives me a radical 3 over, I'm going to cancel the negatives right now, times, keep changing, flip, 2 over 1. Cancel. So this ends up just being a radical 3 over 1 or just radical 3. Okay. All right, so that's tangents. Tangents are a little bit more, I mean, sine, cosine, I mean, that can't be easier, but tangents, they require a little bit more work. Okay. You can use reference angles and angles out of quadrant 1 of the unit circle to determine the values of trig functions. If you did not have your unit circle with you, like this is one way that I like to think about using the reference angle to figure out what the actual sine, cosine, or tangent is, because everything is based off the same family, right? We talked about all those families going on. The nice thing about all those families is that they have the same reference angle. And the cool thing about reference angles, the why we learn reference angles, is that they have the same sines, cosines, and tangents. That's the cool part about it. They have the same sines, cosines, and tangents. So to find the sine, cosine, and tangent of theta, you determine the measure of the reference angle for theta. Basically determine what family it's in. Okay, determine the family. And then use quadrant 1 of that family to find the sine, cosine, or tangent of that reference angle. And then step 3 basically says to apply this diagram, right? You know, you say, okay, if the theta was supposed to be in the third quadrant, well, then obviously, no matter whether you're looking at the sine, cosine, or tangent, then it's negative. Well, excuse me, the tangent would be positive because it's negative divided by negative, right? So it's positive. Okay. Oh, did I? Oh my gosh, look at that. I'm getting ahead of myself. All right. But think about it this way, you know, that's just another way to show this, right? Because cosine is x, sine is y. 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 Tangent is always y divided by x. So this would be positive divided by positive is a positive. Positive divided by negative is a negative. Negative divided by negative is a positive. Negative divided by positive is a negative. Okay. The book likes to give some fancy way to remember which ones are positive in each quadrant. They say all students take calculus. Okay, all students take calculus. I just remembered it as ASTC. ASTC. And it tells you what's positive. Everything's all are positive. Just the sine is positive. Just the tangent is positive. And just the cosine is positive. All students take calculus. That's just telling you which parts are positive. Okay. All right. So use a reference angle to find the sine, cosine, and tangent. So 330 degrees. You've got to think about where, okay, first decide what family is it in. What family it is it in. Okay, well, 330 degrees is right down here with a reference angle of 30 degrees. Okay, so let's use the 30-degree family, right? Think about the 30-degree family. Well, the 30-degree family, this is a 1. This is the short side here. Here's the 1/2, and here's the radical 3 over 2. Okay, so that means I've got radical 3 over 2, comma 1/2, right? So that's my x and y value. Okay, so sine is my y value. Sine of 330 is going to be the y value, 1/2. The cosine of 330 is going to be radical 3 over 2. That's the x value. And the tangent of 330, now that requires a little bit more work. That's the y value divided by the x value, right? So y value is 1/2 divided by the x value of radical 3 over 2. Just a heads up, whenever the radical 3 over 2 is in the denominator, I'm going to have to rationalize it again. So it's 1 over radical 3, which turns into radical 3 over 3. Okay. Now, all students take calculus. Where was this originally? This was originally in the 4th quadrant. Calculus, C, that's the only one that's positive. This is negative, this is negative. Okay. Or you could just think about it, well, since it's in the 4th quadrant, it's only the y value is, sorry, only the x value is positive. It goes positive, negative, and if you take a positive divided by a negative or a negative divided by positive, you get a negative sign. So negative for tangent. Okay. That's just one way to like quickly derive what you need, right? If you didn't have your unit circle sitting there in front of you. I mean, if you had your unit circle sitting there in front of you, 330 degrees, boom, you've got it. The x value is radical 3 over 2. The y value is negative 1/2. So cosine is radical 3 over 2. The sine value is negative 1/2. And then the tangent you just have to run, right? Okay. All right. Let's do another one of those. 270 degrees. Okay, 270 degrees. Think about where that is. Ooh, that's down here. That's that weird one we talked about in the last lesson, right? So it's in the axis family, right? Determine the family. Now you have to say, okay, what are the coordinates here? The coordinates here are the 0, -1, right? It's in the 0, -1. You're not going to really use a reference angle too much because it's an axis family one. But it's 0, -1. So that means the sine is the y value, sine of 270, the y value, -1, excuse me. The cosine of 270 degrees is 0. And the tangent, this is that weird one that we talked about. It would be y divided by x, or sine divided by cosine, if you will. -1 over 0, which is undefined. Yes, the tangent is undefined at 270 degrees. Okay, it is undefined at 270 degrees. Weird. That's weird. Weird. You'll talk about that at much more great length when you talk about graphing tangent in pre-calculus. But I digress for right now. Okay, 3 pi over 4. Think about what family it's in. Okay, so since it's in radians, I'll talk about it in radians. It's the pi over 4 family. Okay, so that's, in other words, in terms of you degree-moded people, 45 degrees. So let's take a look at the first quadrant of the 45 family. Well, remember that's the 45, 45, 90. So this is the radical 2 over 2, right? Now we just have to figure out what quadrant this is in. Well, since it's 3 pi over 4, it's not fully 1 yet, right? It's not fully 1 yet. So that means it's over here, okay? Right, that's the 3 pi over 4. Okay, now that means that since it's in that second quadrant, that is going to give me a negative, positive, right? Negative x value, positive y value. So the sine of 3 pi over 4 is going to be the y value, positive y value, radical 2 over 2. The cosine of 3 pi over 4 is going to be the negative x value. And the tangent of 3 pi over 4. Now that's going to, again, require a little bit more work, but I do know all students, S is the only one that's positive here. Tangent is also going to be negative. But let's talk about tangent. It's going to be negative, the y value, radical 2 over 2, divided by the x value, negative radical 2 over 2. Okay, so now watch here. I've got radical 2 over 2 times negative 2 over radical 2. Keep, change, flip. Look at this. Cancel, 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 cancel. Negative 1. Okay? Negative 1. Everything cancels out, so this is negative 1. You're going to find that the tangent of the pi over 4 family is always some form of 1, either positive 1 or negative 1, depending on what quadrant it's in. Cool point there. All right, last new thing that we got to talk about here is this thing called the arc length formula. Okay, now think about arc length. Now we know that all radians are based on arc length, right? Radians are based on arc length. And I believe last year in geometry you probably learned this formula. arc length is equal to 2 pi r times m over 360. What this basically is that that's the circumference formula, and then basically finding a proportion, or basically, excuse me, the portion of the circle that the angle is covering. It's a value out of 360. Okay, so you're going to take this decimal here, whatever this is, in terms of degrees, right? Out of 360 degrees with full rotation, this angle measure in here out of 360 at this decimal and multiply it by the full length around, right? But what if it was in terms of radians? What if it was in terms of radians? Well, think about this. 2 pi r times, well, what would that be? That would be, what would that be? What was I going at there? What was I looking for there? This would be 2 pi, m over 2 pi. Whoa, sorry, lost my train of thought. It's late. Okay, because 360 is 2 pi, right? Now think about what I've got here. This is all just multiplication in the end, right? That's in the denominator. That's in the numerator. M, R, but we don't use M as an angle measure. We use theta as an angle measure. So my arc length is going to be equal to R times theta if that is in radian measure. Last year in geometry, you did this with degree measure. Now, since we know better, well, not know better, but know different, we can talk about this in terms of radian measures. This S equals R theta, that is the arc length formula when theta is in radians. Okay, that basically is what I said, S equals R theta. As long as theta is in radians. Yeah. Okay. A minute hand on Big Ben's clock tower in London is 14 feet long. Okay, here's Big Ben. Here's Big Ben. Here's Big Ben. Here's the clock tower. I mean, that's pretty good drawing, right? There's Parliament, right? Whatever. Is that the Thames? Okay. So we've got the Big Ben clock tower there. It's 14 feet long, right? There's 14. Let's draw a little bit better picture. Here's the clock tower. Here's 14 feet long. To the nearest tenth of a foot, how far does the tip of the minute hand travel in 1 minute? Okay, so it's got to go from 0 to 1. Right? It wants to know, this question wants to know, what is my arc length? What is S? Okay, well, what is S? S is equal to R times theta. Well, what is R? R is my 14 feet. That's the minute hand, right? S equals 14 times theta. But we need to figure out what that angle measure is in radians. Okay, well, if it's 1 minute, that means, well, there's one out of, well, how many minutes in a full rotation? 60, right? So that means it's 1/60th of a full rotation. Okay, 1/60th of a full rotation. 160 times 2 pi, right? So it's really just 2 pi times 2 pi over 60, or just pi over 30. That's my radian measure. Pi over 30. Okay. Now, because this is a word problem, I'm actually going to go into my calculator and actually run this value. 14 times pi divided by 30. 1.46. 1.46. I have to look at it, see if it's in feet. I think it's in feet. Which is hilarious because they would not use feet over in jolly old England, but whatever. All right. Favorite lesson of the year, folks. That was just awesome. I probably won't be able to sleep tonight. You know what? I'm just going to pull an all-nighter. I'm just so hyped about what we just did right there. All right. It's a bummer I can't teach it to you in real life, IRL, but it'll do. Okay. See you guys.